Okay, so I was saying 6 over 5 will not reduce. So that becomes 5n. That swings up there. Minus 6. 50 divided by 5 will reduce. So that just becomes 10. Multiply the binomials using double distribution or FOIL or the box method, however method you want. Distribute the 2, and this should be what you end up with. Okay, so now we're on to a new kind. This is what we call dots. D stands for difference. Of 2 squares. Dots. The difference of 2 squares. The difference. Well, actually, I need to do these two first. The difference. There's the minus sign. Perfect square, perfect square. Notice there is no B term. Or no BX term. Difference of 2 squares won't ever have the B. We have an A and we have a B. No, sorry, we have a C. Those are both perfect squares. And all we have to do to factor those is take the root of that. Take the square root of 16. The square root of 16 is 4. The square root of 1 is 1. And these numbers are going to be, we're going to have 1 positive 1, and we're going to have 1 negative 1. The reason that these have to be different signs is because we have to multiply 2 things together to get a negative 1. A positive 1 and a negative 1 is how we're going to get that negative 1. 4 times 4 gives me 16. X times x gives me x squared. 1 times negative 1 gives me negative 1. It works that way every time. What's the root of 9? The square root of 9 is 3. The square root of 1 is 1. So this becomes 3k plus 1, 3k minus 1. Difference of 2 squares. Recognize it, okay, because it should be super, super easy to factor. I see the difference. I do not have a B term, but the problem is 3 is not a perfect square, as neither is 12. So it's not the difference of 2 squares. And since it's not, what we're going to do is check for a GCF. Okay, check for a GCF. And the GCF of this one, that's 3 times 1. This is 3 times 4. So 3 is the GCF. Pull it out. That leaves 1 x squared minus 4. Now look what we have, the difference of 2 squares. The leading coefficient is 1. The square root of 1 is 1. The square root of 4 is 2. So this becomes 3 times x plus 2, x minus 2. Let's do it again. 8's not a perfect square. 2's not a perfect square. It's set up for the difference of 2 squares. We got the difference sign right here. And we have no B term, but not a perfect square, not a perfect square. So check for a GCF. That's 2 times 4. That's 2 times 1. I have a GCF of 2. Pull the 2 out. That leaves me 4p squared minus 1. Perfect square, perfect square. And square root of 4 is 2. Square root of 1 is 1. And that's the way they factor every time, the difference of 2 squares. If you are confused about what perfect squares are, here is a list of perfect squares. 1, because that's 1 times 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 25, 36, 49. That's 7 times 7. 8 times 8 is 64. 9 times 9 is 81. 10 times 10, that's 11. That's 12. 169 is 13. 196 is 14. 15 is 225. 16, I don't know. But yeah, I know those by heart, or I can do them in my head. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So, but you need to learn to recognize these. So if you don't kind of have a list of these in your head, you need to get it in your head, because recognizing these as perfect squares is the first step. And guess what? Same thing is true on the next set. These are perfect squares. You're looking at these. What? This doesn't look like perfect squares. Well, for a trinomial to be a perfect square, here's what must be true. A must be a perfect square. Okay. C must be a perfect square. And B must equal the root of A times the root of B times 2. Huh? The root of 9 is 3. The root of 4 is 2. And 2 times 3 is 6 times 2. Root of A times the root of B times 2. 2 times 3, the roots come together to give you 6. 6 times 2, that gives me 12. That means that this is a perfect square, and all you have to do is to factor it is put the root of 9 in front with an n, make this sign match this sign, and put the root of that one at the end and stick a little square up there. Remember, that right there means that 3n plus 2 times 3n plus 2. Okay, so let me squeeze this up. So root of 9 is 3. Root of 25 is 5. 3 times 5 is 15 times 2. Yep, gives me 30. So these two are the numbers that go in the parentheses. 3 has an X with it. Make this sign match that sign. That's a plus. And the root of 5 gives you that. There's the factored form of that. Not a perfect square, not a perfect square, not a perfect square, not a perfect square. But if you check for a GCF, this one's faster. Check for a GCF. This is 5 times 1, 5 times 2, 5 times 1. 5 is a GCF. Pull it out. We have x squared minus 2x plus 1. Pull the 5s out. 1, 2, 1, 1, negative 2, 1. Okay, perfect square. 1 is a perfect square. 1 is a perfect square. The root of that is 1. The root of that is 1. 1 times 1 equals 1 times 2. It matches. So that means that this is the root in front of the x. Make this sign match this sign, and the root of that one. Okay, last one, last example, and then the rest of this is yours. 32 is, I'm going to try, oh shoot, I'm running out of time. 32 is 2 times 16. This is 6, what is it? 6 times 8 is 48. And that's 6 times 3. So those have a common factor. Let me try this one again. What about